Assalamu alaikum. Welcome to Taha Institute of Science and Engineering. I am well and hoping that you are also enjoying good health and a happy life with your family and friends. This is the 11th lecture of the fundamentals of chemistry, in which we are going to cover the topics related to molecular formula, molecular mass, and the formula mass. And now let's today's lecture, that is molecular formula. What is molecular formula? The atoms combine to form molecules. The molecules are formed by the combination of atoms, and that molecules are represented by molecular formula. The molecular formula is the formula that shows the actual number of each element present in a molecule of that compound. What is molecular formula? Molecular formula is the formula that shows actual number of atoms of each element present in a molecule of that compound, whereas we have learned in the last lecture that the empirical formula shows the simplest whole number ratio, whereas the molecular formula shows the actual number of atoms of each element present in a molecule of that compound. And what is the relationship between the molecular formula and the empirical formula? Molecular formula is derived from the empirical formula by following relationship, as molecular formula is equal to the simplest whole number ratio in empirical formula multiplied by the n. N would be any number, n would be any natural number, that is 1, 2, 3 or so on. For example, the molecular formula of benzene, there is 6 atoms of carbon and 6 atoms of hydrogen in benzene. That is derived from the formula CH, that is the empirical formula that's showing the simplest whole number ratio of carbon and hydrogen, that is 1:1, where the value of n is 6. That is the 6, when empirical formula the simplest whole number ratio is multiplied with 6, then we get benzene. And the molecular formula of a compound may be same or a multiple of empirical formula. Some compounds may have same empirical and molecular formula. In case the molecular formula is already showing the simplest whole number ratio. For example, in case of water, we have already the 2:1 of hydrogen and oxygen, that is already simplest ratio, and the molecular formula of hydrochloric acid is also HCl, that is 1:1 between hydrogen and chlorine. And here we have some compounds with their empirical and molecular formula. The compound is hydrogen peroxide, and the empirical formula that is showing the simplest ratio between hydrogen and oxygen, that is 1:1, whereas in molecular formula the H2O2 means 2 atoms of hydrogen, also 2 atoms of oxygen, and in benzene CH, there is the simplest whole number ratio between carbon and hydrogen is 1:1, that's showing the empirical formula, whereas in molecular formula it shows the actual number of carbon atoms and hydrogen atoms in benzene, that is 6. And in the same way, the glucose showing the empirical formula CH2O, it means the glucose having the ratio of carbon, hydrogen and oxygen is 1:2:1, whereas in actual number ratio, that is showing the molecular formula C6H12O6. The molecular mass and the formula mass, and keep in mind always we use molecular mass for the covalent compounds, whereas the formula mass for the ionic compounds. So what is molecular mass? The sum of atomic masses of all the atoms present in one molecule of a molecular substance called molecular mass. For example, molecular mass of chlorine is 71 AMU, that is atomic mass unit, whereas water having the atomic mass, water has the molecular mass, that is 18 atomic mass unit, and the carbon dioxide have 44 atomic mass units. And now we have a numerical example, that is calculate the molecular mass of nitric acid HNO3. As we are seeing here that there in nitric acid there is one atom of hydrogen and one atom of nitrogen and 3 atoms of oxygen, and the atomic masses of and the atomic mass of hydrogen is 1 atomic mass unit, whereas the atomic mass of that is nitrogen is 14 atomic mass unit, and atomic mass of oxygen is 16 AMU. And now we have to calculate the molecular formula, as we know that one atom of hydrogen, so the atomic mass of hydrogen is multiplied by 1, and then the summation sign with the atomic mass of nitrogen is also multiplied by 1, because nitrogen has there is 1 atom of nitrogen in nitric acid, and then again the summation sign with the 3 atoms of oxygen and multiplied with the atomic mass of oxygen. So by putting the values, that is atomic mass of hydrogen, that is 1, and the atomic mass of nitrogen is 14 atomic mass unit, and the atomic mass of oxygen is 16, and by calculating all these values we get the value of 63 AMU. And now what is formula mass? As we have learned that the ionic compounds that form 3-dimensional solid crystals and surrounded by the oppositely charged ions and always represented by the formula units. Formula mass is again the same as molecular mass, but is formula mass is the sum of atomic mass of all the atoms present in one formula unit of a substance. For example, formula mass of sodium chloride is 58.5 atomic mass unit. As we know that the sodium is showing the 23 atomic mass number, and the chlorine is having 35.5 atomic mass units. So the summation of these two atoms, sodium and chlorine, is equal to 58.5. that is the formula mass of sodium chloride. And in the same way we can calculate the formula mass of calcium carbonate, that is 100 atomic mass unit. And again we have this numerical example. Calculate the formula mass of potassium sulfate K2SO4. As we can see that there is 2 atoms of potassium and 1 atom of sulfur and 4 atoms of oxygen. and we know the atomic mass of potassium is 39 AMU and atomic mass of sulfur 32 atomic AMU atomic mass unit, or atomic mass of oxygen, that is 16 atomic mass unit. So the atomic mass of potassium sulfate K2SO4, as we know that we have to multiply the atomic mass of each atom with that number of atom in that formula unit. As we see that there are two atoms of potassium, so atomic mass of potassium is multiplied by 2, and in the case of sulfur, as we see that there is one atom of sulfur, so 1 multiplied by atomic mass of sulfur, and in the same way there is 4 atoms of oxygen, so 4 is multiplied by the atomic mass of oxygen. Putting the values of these atomic masses, we can calculate the formula mass for the formula unit of potassium sulfate, that is equal to 174 atomic mass unit. Now we have an assignment for you, that is 5 questions. The question number 1 is what is the relationship between the empirical formula and formula unit? Question number 2, how can you differentiate between molecular formula and empirical formula? Question number 3, identify the following as molecular or ionic compounds: hydrogen peroxide, methane gas, and the glucose and the sugar, barium carbonate and potassium bromide. You have to put answers that what is the empirical formula of acetic acid CH3COOH, and also find out its molecular mass, and calculate the formula masses of sodium sulfate, zinc sulfate and cuprous carbonate. Now question number 1, that is what is the relationship between empirical formula and formula unit? As we know that formula unit we use always for the representation of an ionic compound, that is the simplest unit, whereas empirical formula is the simplest whole number ratio of ions present in the ionic compound, or in other words, ionic compounds have only empirical formula which is same to formula unit. For example, formula unit of common salt consists of 1 sodium ion and 1 chlorine ion, and its empirical formula is NaC. And identify the following as molecular or ionic compounds. As we know that hydrogen peroxide is a molecular compound, whereas the methane is a molecular compound, and the C6H12O6, that is glucose, is also a molecular compound, and the sugar C12H22O11 is also a molecular compound, whereas barium carbonate is an ionic compound, and potassium bromide is also an ionic. The next question we have, what is the empirical formula of acetic acid, that is CH3COOH, and also find out its molecular mass. So molecular formula of acetic acid CH3COOH can be written as C2H4O2. As we can see that there is 2 atoms of carbon, so C2, there is 2 atoms of carbon, and hydrogen, there are 4 atoms of hydrogen, 3 plus 1, there are 4 atoms of hydrogen and 2 atoms of oxygen, and the ratio of carbon, hydrogen and oxygen are 2:4:2. So then divide each of these numbers by 2 to get the ratio, C ratio, H ratio, O, that is equal to 1:2:1. That is formed the empirical formula, that is CH2O. And now we have to find out the molecular mass of CH3COOH acetic acid. And as we know, the molecular formula of CH3COOH is C2H4O2, and we know that there is 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of oxygen. So we can calculate the molecular mass of acetic acid by each atomic mass is multiplied by its number of atoms, and then sum of all of the atoms present in the acetic acid. 2 number of atoms of carbon, so the atomic mass of carbon is multiplied by 2, and there are 4 atoms of hydrogen, so atomic mass of hydrogen is multiplied by 4. There are 2 atoms of oxygen, so 2 multiplied by atomic mass of oxygen. So taking the values of atomic masses of carbon, that is 12, and atomic mass of hydrogen, that is 1, and the atomic mass of oxygen, that is 16, and by simple calculation we can get the molecular mass of the acetic acid, that is 60 atomic mass. And now the next question we have to calculate the formula masses of sodium sulfate, zinc sulfate, and cuprous carbonate. Sodium sulfate, there are 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. So the atomic mass of sodium is multiplied by its number of atoms, that is 2 multiplied by the atomic mass of sodium. So there is 1 atom of sulfur, so 1 is multiplied by the atomic mass of sulfur. In the same way, there are 4 atoms of oxygen, hence the atomic mass of oxygen is multiplied by 4. By just putting the values of atomic masses as the atomic mass of sodium, so 2 multiplied by 23, that is the mass of sodium, plus the 32 atomic mass unit, that is the atomic mass of sulfur, and the 4, that is the number of atoms of oxygen, the atomic mass of oxygen, that is 16 atomic mass unit. By just simply multiplying the atomic masses with their number of atoms, so by simple calculation we can get the 142 atomic mass unit, that is the formula mass of sodium sulfate. And now zinc sulfate, as we know that there is 1 atom of zinc and 1 atom of sulfur and 4 atoms of oxygen, so atomic mass of each element is multiplied by its number of atoms present in that formula unit. So atomic mass of zinc, that is equal to 65.39 AMU, plus atomic masses of sulfur, that is equal to 32 atomic mass units. And as we have 4 atoms of oxygen, so 4 multiplied by atomic mass of oxygen, that is 16 atomic mass units. By just simply by putting the values of atomic masses, we can calculate the formula mass of zinc sulfate, that is equal to 161.39 atomic mass unit. We have cuprous carbonate, and as we see that there is 1 atom of copper and 1 atom of carbon and 3 atoms of oxygen. So there is 1 atom of copper, so 1 multiplied by the atomic mass of copper, plus the atomic mass of carbon is multiplied by 1. Why? Because there is 1 atom of carbon. So the atomic mass of oxygen multiplied by 3. Why? Because there are 3 atoms of oxygen in cuprous carbonate. So by just putting the values of their atomic masses, as atomic mass of copper is 63.55 atomic mass unit, and the atomic mass of carbon is 12 atomic mass unit, and the atomic mass of oxygen 16 atomic mass units. And by just simple calculations we can get the answer, that is 123.55 atomic mass unit. That is the formula mass for the cuprous carbonate. This is the lecture of the day, and in the next lecture we will discuss the chemical species. So stay with us and keep watching our videos for more knowledge. Kindly like, share our videos, and do not forget to subscribe the channel. If you like our work, please press the bell icon button. May Allah bless you. Thank you.